Hello there. My name is Professor Richard Johnston. I'm a professor of material science at Swansea University in the UK. I run an imaging facility, so I X-ray a lot of things. The first thing we have here that I'm going to show you is a Minotaur beetle, which is a type of dung beetle. So we have that placed nicely within our field of view. You can see all around we're looking at the surface, but this was imaged using X-rays, so that means we can see the inside of this sample when we cut into that. So we use a technique called X-ray microscopy or X-ray microcomputed tomography. So it's non-destructive. It means we can take this beetle, and as long as it's stationary while we image, and that could take between 30 minutes to 24 hours to image. This one was a bit quicker. It's a low density material, so we could image this in an hour or two. We get really high level of detail over the structure. And that means when we come to put that into SyglassVR, we can interrogate that structure. We can fly around it. We can look at all of the different shapes and morphologies that are on that body, or, as I mentioned, inside. This is a museum specimen, so it happens to be quite dried out. It wasn't preserved in any fluid, so this is a dry, pinned specimen. You might have seen insects that are pinned, and so this would have had a metal pin running through it. For X-ray imaging, metal next to a lower density beetle isn't a good idea, and so what I've done here is replace that with a carbon fiber pin, and we imaged it actually upside down. But yes, so we have our Minotaur beetle. The name, as you can see, it's got these, related to these horns that it has on the front of its carapace. This is the head, 6 legs like any insect. And as a dung beetle, this isn't the type that makes or rolls balls of dung. This actually burrows and digs into the ground or digs into piles of dung here in the UK. And so these front legs effectively are really important for digging. You can see this portion, it's pretty hench. You've got large forelimbs here which are packed full of muscle, and they drive these digging and earth removal or dung removal front legs effectively. So you've got these large paddles which will move the earth out of the way or move the dung. But you also have these spikes which are used, or these tibial spines, which will be used to dig into the earth or grip the earth or pierce into the dung and then burrow and tunnel into that. So this here is a male specimen. As pairs, they work quite well as a team. So the female will dig the tunnel into the dung and slightly below, and the male will then be behind, and it will work as a team. It'll be removing that earth from the tunnel, so moving that behind to excavate. So why am I looking at these? One, because we can, and X-raying things and then looking at them in SyglassVR is awesome. But two, we work on bio-inspiration. So I X-ray things, and sometimes we know what we're looking for, trying to understand the part of their behavior and function, if we're looking at an animal or an insect or things like that are living or used to be living. But one aspect of our research is looking to nature, so bioprospecting. So looking for materials, systems, morphologies that might be useful for engineering design and to effectively support society as we develop, but learning from millions of years worth of evolution. And so instantly, we know these forelimbs are really important to their behavior in the field, literally in a field. And so studying those, that drives me to think about, okay, is there any kind of unique function, unique morphology related to that function, or something that might be useful? And instantly we're drawn to see these structures here. You've got these joints, hinge joints for their forelimbs. There's a little overlap there to stop it over rotating, but really what we then might like to do is cut into that to try and understand that structure in detail, how that interlocks, how it moves. There we can see we've got dried out muscle, but that would have been packed full of muscle before it desiccated. So yeah, trying to understand how this joint moves and rotates, and the biomechanics then of how that moves heavy earth, or excavates tunnels and moves earth and dung around. So this is the first step to understanding that. What we can do is segment out the two different halves, so top and bottom, either side of that joint, and 3D print those, so we can create large physical volumes. So this is great in SyglassVR, interrogating these gigabytes of data, slicing through, trying to understand the morphology. But then what we can also do is segment that out, digitally segment that out, 3D print the two halves of just this section here, and look at the rotation of those and the movement to get a real good feel for those at a much larger scale than the real beetle size, which is smaller than this, which is really hard to look at even under a microscope, trying to manipulate that and understand the movement. So firstly, scaling it up as big as my car, or as big as a room in my house, and then 3D printing parts of that morphology to try and understand them a bit better. So yeah, really interesting being able to interrogate this in 3 dimensions. It's a different perspective. I love jumping into this data. As soon as we scan something, I'm really excited about putting that into SyglassVR and seeing things in a way that no one has ever seen before, typically. Even this, people will have seen Minotaur beetles walking around. There'll be early museum collections from hundreds of years ago, but really getting this perspective and being able to think, all right, I'm really interested in this bit, let's have a look. This is a hidden part. Look at the perfect alignment of all these body parts. It's just ridiculous. And so yeah, having this perspective, or going inside the head, here we go, we can go up to the horn, or one of the horns, and then pop out the carapace. Trying to look at the elytra, the wing covers are really interesting as well. And so I haven't even got onto those. But they're really good, really strong materials for protecting, really tough, crack-resistant materials. The mouth parts, the antenna, there's just so much we can do. So for interrogating natural history specimens is really, really useful, and you feel like even though these were discovered many years ago, we're seeing new things instantly. As soon as we x-ray them and get into this data, we are transported into a world that no one's ever been in before, the insides of things. So yeah, that's a nice experience, a nice interrogation of a Minotaur beetle. And check back for more in future. I'll shut this off. I've been Professor Rich Johnston, and I hope you enjoyed.